Hey everyone. Today we're tackling rates of change, topics 1.2 and 1.3 from AP Precalculus. So let's break it down quickly and clearly. So, what is rate of change? The rate of change essentially tells you how one quantity changes compared to another. So we can write down the average rate of change is equal to the change in output divided by the change in input. And you're going to see a general formula that's written kind of like this. Sometimes you might see change in y over change in x, but this is the formula that you're going to want to remember every time you want to calculate rate of change. F of b minus f of a divided by b minus a. And so you're going to be given an interval. Maybe they're going to ask you to calculate the rate of change from x equals 1 to x equals 2. So you'd plug in, 2 for b and 1 for a, and then the value at x equals 2 and the value at x equals 1 for f of b and f of a. So let's talk about average versus instantaneous rate of change. So an average rate of change measures the change over an interval. All right. So let's say this is x equals 3, and let's say this is the 5 mark. So that pink highlighted part of the graph is basically measuring the average rate of change from x equals 3 to x equals 5, from 3 to 5. Okay. Instantaneous rate of change, let's say we wanted to know the average rate of change right here at that point. So to calculate instantaneous rate of change, we can approximate it using really small intervals around that point. So maybe we can plug in, let's say we want to know the instantaneous rate of change at x equals 1. So we can plug in like 0.9, 1.1. So we can just plug in values around 1, and that'll be a really good tool for us to predict the instantaneous rate of change at that specific point. Let's talk about positive and negative rates, because you're going to see that. So if the average rate of change is positive, both quantities are going to move together. All right. And they either both increase or they both decrease. So here I have two example graphs on the side. So I just made this up, AP grade and time spent studying. Sometimes it doesn't always work like that, but here's a sample graph. Okay. So basically this graph is saying as one quantity increases, the other increases. As you spend more time studying, your AP grade increases, right? They both move together. They're both increasing. This one has a positive average rate of change. On the other side, we have a different graph. And this time, maybe it's a football in the air, a basketball in the air after coming out of the net, something like that, or the hoop. So you have the height of the ball, and it starts off high, and it is falling towards the ground. So as time keeps moving on, the ball is dropping towards the ground. So yes, time is increasing, but the other one decreases. So that's another rule you're going to want to remember. If it's a negative rate of change, one increases, see, time is increasing, but the other decreases. The height of the ball is decreasing. Okay. Let's move on to how to compare rates at two different points. So if you want to compare rates at two different points, you can calculate the average rate of change near each point. So let's say you want to calculate the average rate of change. If you're given like 3, 1, and then the other point is like 5, 8. You can calculate the average rate of change at those two different points using values close by, as we talked about for instantaneous rate of change, and then you can just compare the rates of change. So whichever one has a bigger value is going to be increasing at a faster rate, smaller value increasing at a slower rate, or decreasing, if it's a negative value.